Good morning, children. Welcome back to our maths class. Let us continue with the chapter Square and Square Roots. Today, our topic is square product. Example of square product. 5 square into 4 square. How we will do this? We will take the square of 5, then we will take the square of 4 and we will multiply the answer. That is equal to 5 square is 5 5s are 25 into 4 square, that means 4 into 4, that is 16, and we have to multiply 25 into 16 and we get the answer 400. Instead of doing like this, we can do this in another way, an easier way. How? We will take the product of this because the square is common for both. So we take the square outside. 5 into 4 whole square. Okay. We take the product of the base and give the square to the product. That is 5 4s are 20 whole square. That is equal to 20 square means 20 into 20. Now we can multiply easily, isn't it? 2 2s are 4. Then put the 2 zeros. Answer is 400. So, we can say the product of the squares of two numbers is equal to the square of their product. And in algebraic expression, we can write it as x square y square is equal to xy whole square for any number x and y. Another example, 1.5 square into 0.2 square. We can write this as 1.5 into 0.2 because square is common for both. So, we multiply the base 1.5 into 0.2 whole squares. Okay, the square is given for the product. That is equal to, we will multiply the decimal number. We will avoid the decimal point and multiply the number. Then count and put the decimal point. So 15 into 2 is equal to 30. We have to count the number of numbers after the decimal point. 1, 2. So after 2 number, we have to put the decimal point. That is equal to 0.30 whole square. 0.30 means we can write it as 0.3 itself. So that means 0.3 into 0.3. Or 0.3 into 0.3, that is equal to 3 3s are 9. Then how many numbers are there after the decimal point? Here one number, here one number. So 2 numbers are there. So after 2 number, we have to put decimal point. 1, 2, decimal point. So answer is 0.09. 0.09 is the answer. Next topic, reverse computation. Example for reverse computation. Example, 5 square is equal to 25. This we can say it as square of 5. We take the square of 5. So, square of 5 is equal to 25. In reverse, we will say it as square root of 25. Square root of 25 is equal to 5. Square root is indicated by using this symbol. This is the symbol for representing square root. So this we can write it as square root of. We will read this as square root of 25 is equal to 5. Another example, square root of 4. What is the square root of 4? 2. Because when we multiply 2 times, we get 4. So square root of 4 is equal to 2. Another example, square root of 169 is equal to, what is the square root of 169? 13, because 13 into 13 is 169. In algebraic expression, we can say it as for numbers x and y, if x square is equal to y, then square root of y is equal to x. Next question, find out the square roots of. We have to first find the square root of 100. We know 10 into 10 gives 100. So, square root of 100 is 10 because 10 into 10 is 100. Second question, square root of 1 by 4. This we can write it as square root of 1 by square root of 4. That is equal to, what is the square root of 1? 1 into 1 gives 1. So square root of 1 is 1 itself. By square root of 4 is equal to 2, because 2 into 2 gives 4. So answer is 1 by 2. Square root of 1 by 4 is equal to 1 by 2. Third question, square root of 1.44. You just avoid and see 144. Which is the square root of 144? We know 12 into 12 gives 144. So 12 is the square root of 144. But here it is 1.44. How many numbers are there after the decimal point? 2 numbers are there. So we have to take the half of that. Half of 2 is 1. Isn't it? 1 plus 1 is 2. So here we have to put the decimal point after one number, because when we take the square of 1.2, that means 1.2 into 1.2. That is equal to, we will multiply 12 into 12 and we get 144. There we will put the decimal point. We will count the number of numbers after the decimal point. 1, 2. So after 2 number, we will put the decimal point, isn't it? So here we will see how many numbers are there after the decimal point. Here we have to take the half of it. If it is 2 numbers, if 2 number is there after the decimal point, you have to put the decimal point after one number. If there is 4 decimal point, you have to put the decimal point after 2 number. Okay? Fourth question, square root of 0.01. What is the square root of 1? 1 itself. Where we will put the decimal point? Here there is 2 number after the decimal point. So we have to put the decimal point after one number. After one number, we will put the decimal point. So answer is 0.1. Next topic, square root factors. Here we will see how to find the square root of bigger number using factorization method. Now, let's see how to find the square root of 1225. Means we have to find the square root of 1225. For that, what you have to do is that you have to find the factors, prime factors of 1225. How you will find? Use the factor method. Now, let's factorize and see. 1225. This will go in 5's table because it ends with 5. So we take 5's table. In 5's table, 12. 2 times 10 will go. So we write 2 here and give the balance 2 to the next number. So it becomes 22. In 5's table, 20 will go 4 times. So after balance 2, give it to the next number. So it becomes 25. 25 will go 5 times. Again, this is divisible by 5. So in 5's table, 4 times 20. Balance 4, give it to the next number. 45 will go 9 times. Again, we will factorize. 49 will go in 7's table. 7's table, 49 will go 7 times. Again, it is divisible by 7. So, we factorize, we will get like this. So, 1225, we can write it as 5 into 5 into 7 into 7. For finding the square root of 1225, we pair this. Okay, 5 get paired, 2 7s get paired. So, square root of 1225 is, for this we write 1 5 into, for this we write 1 7. That is equal to 5 7s are 35. 35 is the square root of 1225. Next question, find the square root of 9216. So to find the square root, first of all, we have to factorize this number. 9216. This is divisible by 2. So let us factorize by 2. 9, 4 times, 8 will go, balance 1, give it to the next number. 6 times, 12 will go 6 times, 1 will not go. So instead, we write 0. Then 60, so it becomes 16. 16 will go 8 times. Again, it is divisible by 2. 4 will go 2 times. 6 will go 3 times. Instead of 0, we can write 0 itself. 8 will go 4 times. Again, it is divisible by 2. 2 will go one time. 2 stable, one time 2 will go, balance 1, give it to the next number, so it becomes 10. 10 will go 5 times. 4 will go 2 times. Again it is divisible by 2. 11, how many times? 5 times 10 will go. Balance 1, give it to the next number. 7 times 14 will go. Balance will give it to the next number. 12 will go 6 times. Again it is divisible by 2. 2 times 4 will go. Balance 1, give it to the next number. Then 8 times 16 will go. Balance 1, give it to the next number. 16 will go 8 times. Again it is divisible by 2. 2 will go one time, 8 will go 4 times, 8 will go 4 times. Next, again it is divisible by 2. 14 will go 7 times and 4 will go 2 times. Again it is divisible by 2. 3 times 6 will go, balance 1, give it to the next number. 12 will go 6 times. Again it is divisible by 2. 1 time 2 will go, balance 1, give it to the next number. 16 will go 8 times. Again it is divisible by 2. How many times? 9 times. Then 9 will go in 3 stable 3 times. Then 3 will go in 3 stable 1 time. When we factorize 9216, we get like this. So 9216, we can write it as 10 2's and 2 3's. Now for root of 9216, we can pair the number. Okay, we can pair like this and take 1 from each pair. Of square root of 9216 is equal to 2. How many pairs of 2? 1, 2, 3, 4, 5. 1, 2, 3, 4, 5 into then 1, 3. So answer is 2 2's are 4, 4 2's are 8, 8 2's are 16, 16 into 2 32, 32 into 3 96. Square root of 9216 is equal to 96. Next question, find the square root of 3025. To find the square root, first we have to factorize this number. 3025. When we factorize, we get like this. So 3025, we can write it as 5 into 5 into 11 into 11. So square root of 3025, we can write it as, we will pair and take 1 each. 5 into 11. 5 11s are 55. So 55 is the square root of 3025.
Now let's do some questions on page number 87. First question, the area of a square plot is 1024 square meters. What is the length of its sides?
According to the question, it is given that area of square plot is 1024 square meter. Area of square, this is a square plot. So area of a square is what? Side into side is area. Area of the square is side into side. That is equal to 1024 square meter. We have to find what is one side. So for one side is equal to square root of 1024. How we will find the square root of 1024? We can find it by factorizing 1024. When we factorize 1024, we get like this. So 1004 is equal to how many 2's? 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. 10 2's. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. So square root of 1024 is equal to, we can pair and take 1 each. We will pair like this. Okay. And we can find the square root of 1024 as 2 into 2 into 2 into 2 into 2. That is equal to 2 2's are 4, 4 2's are 8, 8 2's are 16, 16 into 2, 32. So one side is equal to 32 meter. Length of one side is 32 meter.
Next question. In a hall, 625 chairs are arranged in rows and columns with the number of rows equal to number of columns. The chair in one row and one column are removed. How many chairs remain?
According to the question, it is given that number of chairs in hall is equal to 625, and it is also said that number of chairs in row is equal to number of chairs in column. So we can write, since number of row is equal to number of columns, number of chair in one row or one column is equal to square root of 625. To find the square root of 625, we can factorize 625. When we factorize 625, we get like this. So after pairing, we get square root of 625 is 5 5s are 25. So number of chair in one row or one column is equal to 25. Next part of the question, the number of chair in one row and one column is removed. In present, number of chair in one row is equal to 25. So we can write number of chairs removed from one row is equal to 25. So if one row is removed, number of chair in one column become 25 minus 1, that is 24. Therefore, we can write number of chairs removed from one column is equal to 24. See children, here you may get confused. Number of row and number of column is 25. But why the number of chair removed from column is 24, isn't it? See, I will show you another example to make it clear. I am going to arrange 9 chairs in 3 rows and 3 columns. 1, 2, 3, 4, 5, 6, 7, 8, 9. Okay, so how many chair is there in one row? 3 chair is there. How many chair is there in one column? 3 chair is there in one column. First, I am going to remove the chairs in first row. Okay, when I remove the chair in first row, number of chair in one column become what? 2, isn't it? That is 3 minus 1, that is equal to 2. That is what I had done here. Number of row and number of column is 25. When I removed one row, the column, number of chair in one column become 25 minus 1, that is 24. Therefore, total number of chairs removed is equal to 25 plus 24. 25 plus 24, that is equal to 49. The question, we have to find how many chairs remain. So we can write remaining chairs is equal to, from the total number of chair, we subtract 49. 625 minus 49. Answer is 576.
Next question. The sum of a certain number of consecutive odd numbers starting with 1 is 5184. How many odd numbers are added?
According to the question, sum of certain consecutive odd number. When we add certain consecutive odd number from 1, we get the answer 5184. We have to find how many odd numbers we add to get 5184. Before coming to the question, let me show you one fact. The odd number 1. 1 is a perfect square. When we add first two odd number, 1 plus 3 is equal to 4. 4 is a square of 2. 2 square is 4. 1 is a square of 1 itself. Okay, when we add 3 consecutive odd number, 1 plus 3 plus 5, answer is 9. That is a perfect square of 3. When we add first 4 odd number, 1 plus 3 plus 5 plus 7 is equal to 16. That is the perfect square of 4. When we add first 5 odd number, 1 plus 3 plus 5 plus 7 plus 9, we get the answer 25. It's a perfect square of 5. See, when we add first 5 odd numbers, we get the perfect square of 5. When we add first 4 odd number, we get the perfect square of 4. When we add first 3 odd number, we get the perfect square of 3. So, to find how many odd number we add to get 5184, we need to just find the square root of this. Number of odd number added to get 5184 is square root of
5184.
To get the square root of 5184, we can factorize 5184. When we factorize 5184, we get the factors like this. So, to get the square root of 5184, we will pair it like this and take 1 from each pair. That is equal to 2 into 2 into 2 into 3 into 3. Answer is 2 2s are 4, 4 2s are 8, 8 3s are 24, 24 into 3 is equal to 72. So, number of odd number added to get 5184 is 72. So, we can say 72 odd numbers we add like this to get 5184.
Next question. The sum of two consecutive natural numbers and the square of the first is 5329. What are the numbers?
In the question, it is given that the sum of two consecutive natural number and the square of the first number gives 5329. Before coming to the question, let us see with an example. If I am taking the first number as 5, okay. Next consecutive number is 6. 5 plus 6 plus the square of the first number, that is 5 square. What is the answer? 5 plus 6 is 11 plus 5 square is 25. When we add, we get 36. 36 is what? Square of the second number, that is 6 square. We have seen this somewhere in the same chapter. This is the form that we do in the next square, under the topic next square. So, to find the two consecutive natural number, what we have to do is that we have to find the square root of this. So, we get the second number. Okay, when we find the square root of this, we get the second number. Same way, when we find the square root of this, we get the second number. When we subtract 1 from it, we get the first number also. So, we can write x plus 1 is equal to square root of 5329. Now, let us factorize 5329 to get the square root of it. This number is only divisible by the number 73 times. So, we factorize like this. Square root of 5329 is 73. So, we get x plus 1. X plus 1 is equal to 73. So, what will be x? X means we have to subtract 1 from this. 73 minus 1, that is equal to 72. So, we can write two consecutive natural numbers are 72 and 73.